Hi, how are things? So today I'm going to talk about another important concept in probability and statistics, namely the variance of a random variable or probability distribution. As in these discussions, I will talk about variance of a simple random variable because since this is a verbal presentation, it is easiest to talk about simple random variables. So if we quickly recall that a simple random variable is one which takes finitely many values with positive probabilities, and we also recall that its expected value is nothing but the weighted average of these values, weights being the probabilities. Now one valid question is that how close or how far are the values of a random variable from the mean. To give an example, suppose there is a random variable x which takes the values -1 and +1 each with probability half, and there is another random variable y which takes the values -100 and +100 each with probability half. So it's a straightforward exercise now to compute the expectation of x and y. Both turn out to be equal to 0. But in the first case, the values, that is -1 and +1, are much closer to 0 than the values of the other random variable. So you can easily have two random variables or two probability distributions which have exactly same mean, but the values are far away from the mean in one case in compared to the other. So we need some measure of this scatteredness, or what we call dispersion. Dispersion means amount of scatteredness. So we have a set of numbers. How they are closely scattered means the numbers are numerically close to one another. Widely scattered means some of the values can be far away from the rest. So this is the idea. So we need a measure or one number which will give an idea about how much scatteredness is there. Now whenever we talk about scatteredness in a set of numbers, we need a benchmark. So from where are we measuring the distance? So the benchmark is the mean or the expected value. So we measure the distance of the values of a random variable from its mean. Now if you just take the difference of each value from the mean and find out the weighted average, then I leave it again as an exercise, as an arithmetic problem, that verify that for any set of numbers x1, x2, xn, the summation of xi minus x bar, that is the deviations from the mean, they add up to 0. This is a simple numerical exercise. So if you just add up the deviations from the mean, you will get 0 no matter how far or how close the values are. So we need, what we do is that we square up these deviations and take the average. So what will be the idea, that if a random variable x takes the values x1, x2, xk with probability p1, p2, pk, then you know how to find the mean. And so that would be x1 into p1 plus x2 into p2 plus all the way up to xk into pk. So that is the expectation of x. Now take the deviation of each value, x1 minus expectation of x, x2 minus expectation of x, all the way up to xk minus expectation of x. Take their squares and then average them. So you get the variance. So variance is again an average. But average of what? Average of deviations, not individual deviations, rather squared deviations. So so variance of a simple random variable is a weighted average of the squared deviations of the values from the expected value. So the formula would be p1 into x1 minus x bar whole square plus x p2 into x2 minus x bar whole square all the way up to pk into xk minus x bar whole square. By x bar I refer to their mean. So this would be the variance. Now if the random variable takes all the values x1, x2, xk each equal probability 1 by k, then this formula simply becomes 1 by k summation of xi minus x bar whole square, where x bar is the mean. Now you can check few things, that this is a non-negative number, that is trivial because you are adding up all squares. Now I would leave with this question, what does this variance equal to 0 imply? So I want you to find out that. and if all the numbers are equal, so what suppose x is the random variable that takes the value 10 with probability